I come from the future.
Welcome to The Big Puzzle. In this podcast, we explore the subtle connections between science, religion, politics, economics, and history. One piece at a time, we unveil the big picture of this shared experience that we call life.
So this one will be slightly different than the rest. I want to tell you a story, and we will leave the connections for a future video. But as an introduction, in some videos in the past, especially talking about if we will ever be able to live in another planet, and in particular Elon Musk's plans to go to Mars, I mentioned that most likely with the technology that we have today, or even in the foreseeable future, that will never happen. Rockets won't be able to take us there. But there could be some breakthrough in physics. And today I would want to talk about that breakthrough. Because it happened, or at least it will happen. So it happened according to a visitor I had from the future. And he explained to me how things developed, and I took some notes. And I want to tell you what is going to be happening in the next few years, and how humanity is going to finally be able to reach, I don't know if the stars, but at least some other planets. So this visitor told me that in the year 2027 there's this researcher whose name is Gunther Krauss, that he was working in a lab in Bern, and his experiment was something not very interesting. He was running experiments on the impact of some processes on the oxide layer of aluminum pieces. Right? He was running these experiments that require very, very precise measurements. So he had specialized equipment that he used to measure, after the different treatments, what would be the impact on that very thin oxide layer in aluminum surfaces. Now, the problem that he had was that randomly that experiment would give some wrong measurements. So how could he tell that they were wrong? Well, because the values had always, on the thickness of the oxide layer, had always had to be going down. There was no way that it could build up according to the experiment that he was running. But randomly he would have measurements that would go up and then will go down again. And well, he couldn't explain that, and he thought maybe there's something in the setup of the experiment. So he started over, setting up everything, checking absolutely everything. But he still got those. And the worst part, as any researcher knows, or even a computer programmer knows, is so those happen randomly. He couldn't replicate it. He didn't know when. Obviously, he didn't know why, but those kept happening over and over. So that was ruining his whole research, and he was getting paid for that. So that was a big problem. At some point, he decided to, get new equipment, new measurement equipment. He thought that there might be some issues with the equipment, but it was some equipment that he had used extensively in the past. He never had an issue. So he basically got another exact same model of the measurement equipment. He repeated the setup, but again, he was getting the same random wrong measurement, the same spikes in those measurements. So he was really concerned about that, and until one morning, that he could run a lot of those measurements without any errors whatsoever. And that left even more perplexed, because he usually had 10, 20 errors, every session of a few hours. So he said, well, I don't know. I can't explain why it happened. I can't explain why it's not happening now. But when he was having lunch in the cafeteria, he sat by Dr. Rees, who was a colleague, another physicist that was running his own experiments in the same lab, in the same building. And they were talking about, how tight the schedules were and the deadlines, and Dr. Rees mentioned something. He says, yeah, he definitely understood that, and he was very frustrated because that whole morning one of his equipment was not functioning, and he was waiting for a technician to come and fix it. And then, Dr. Krauss thought, whole morning, what equipment is that? And it was a microwave generator. So the experiment that Dr. Rees was running used microwaves, and that's the equipment that had failed. So, a light bulb turned on Dr. Krauss's head, and he said, well, maybe this could explain what's going on with my experiment. So they talk about that. Dr. Krauss explained to Dr. Rees what was going on, and they agreed on running some meta experiments, right? So once the equipment was fixed, they were going to coordinate, synchronize the experiment to see if whenever the microwave generator will turn on, and it will turn on in pulses. So basically that matched really well to what Dr. Krauss was seeing. They would kind of measure that and see if there was a correlation. So late that day, when the equipment was finally fixed, they did that. And even though the labs were pretty much far apart in the building, every time that that generator would send a pulse, the equipment will give these weird readings. And well, that explained it, or did it, because that had never happened in the past, and he had been around other labs for a long time. So the first thing that Dr. Krauss saw was, well, I need to talk to the manufacturer of my equipment and ask them. So he contacted them, and they told him, we've never seen any problem. There's no reason why microwave pulses would affect our instruments. We never had any complaint, and from the physics point of view, there's nothing that should be affected, especially at that distance. So Dr. Krauss said, well, the way I can continue my experiments and get rid of the problem, I could do the whole setup in a Faraday cage. So Faraday cage, basically a mesh of wire, around the experiment that would prevent the microwaves to get into the setting. And he did so, a little more expensive, a little more cumbersome every time, having to open it to do stuff and close it. But that solved the problem. Now, still something was not right. So Dr. Krauss wanted to be able to explain what was going on. So talking again with Dr. Rees, they decided to call the manufacturer of the equipment and offer them, hey, we've seen this, we have evidence that it's happening. Do you want us to try to find why? The manufacturer said, not really, but so they were not willing to pay for that. But they say, well, we have some equipment that we can give to you that you could turn apart if you want. The only condition is that you tell us what you find after you do what you do, but you're on your own. So Dr. Krauss and Dr. Reed started working late evenings to try to figure out what was going on, what produced that wrong measurement. And as any good scientist, what they did is they started isolating factors, right? So they took different components and, they produced the pulses with the other equipment, and so which of those components showed any different at all. So by doing that over and over, they identified one little component that actually it was affected. And that component was not critical, but the only particular thing that it has was the composition. It was a cadmium alloy. And for whatever reason, it was affected. And so they did a new setup to see how it was affected. It's a long story, and I didn't get all the detail from this visitor from the future. But what I remember is that they somehow create kind of a pendulum where that piece was, hanging. And the interesting thing is that when they turned the microwave generator, that pendulum would swing slightly. And they thought, well, this looks like something magnetic, something is attracting it, right? But the other weird thing is that the weight of the object also changed slightly. So again, everything tended to indicate that there's some magnetism or some electric field or something that was, attracting it or repulsing it. So they changed the setup, they kind of move it around, but it always happened the same thing. And they even said, well, that this generator is so far apart, it's very difficult that we'll have that kind of effect. So they decided to move the microwave generator to another lab on the other side of the building, expecting now the pendulum to shift towards the equipment. But no, still, shifted in the same direction. And no matter what they did or where they conducted the experiment, it always happened the same way. And the funny thing, again, because everything became, you could explain something, but you couldn't explain more things like usually happens in science. And, the thing is that it would always move towards west. Again, strong indicator that has to do with magnetism, probably the magnetic field of the Earth. So they say, okay, if it's magnetic, let's add magnets to the setup and try to, a fairly strong magnet. It's hundreds of thousands more stronger than the Earth magnetic field. So, that would definitely be the one that would dominate the behavior. For some reason, they thought, well, the microwave would turn the cadmium alloy magnetic, and looked like that way. But no matter how many magnets they put around, the effect was always the same. So that little pendulum will always shift the same amount in the same direction. So what to do next, right? Another thing that they notice is, okay, what if we change the frequency of the microwaves? And they realized that effect only happened at the exact same frequency of the original experiment. If they change it just slightly, that completely disappeared, right? And the pendulum would definitely go down. The other big question is, why would the weight of this piece change in presence of a microwave? and it's not a magnetic thing. So, well, like scientists do when they can't explain something, they start taking a lot of measurements and then try to read into those measurements. And in this process, they were helped by some AI that in 2027, well, by that time it was already 2028, early 2028, it was fairly good at finding patterns and helping explain things. And one of the things that the AI did is identify a factor that would explain the whole equation, that would, let's say, that would make the whole equation work. And it realized that that factor was equivalent to G, capital G, so the gravitational constant of the universe. This is by chance? They didn't know. There was nothing that would indicate that gravitation could be anything, could have anything to do with what they were observing. But yeah, it matched perfectly, right? So they named that the big G theory. And for many, many months, they went around trying to involve other people, universities, other researchers, to show what they found. And, you know, many people were not interested. They wouldn't believe, or they didn't care. They had their own scientific problems to deal with. But they kept working on their own time and on their own budget. They communicated their findings to the manufacturer of the equipment, but it was not of much use. I think that the manufacturer just added, you know, a note saying if you observe this, it could be related to some microwaves, or the proposed solution is stop the microwaves or use a Faraday cage or whatever. But that was the end of it. So they started working on different theories of what was going on. So they started changing the shape. They studied in more detail the chemical properties of this alloy, and they created slightly different alloys of cadmium, and to their surprise, some of those new alloys will have this effect much bigger than the original one. And they also found a correlation between the shape of the object and how it was oriented and the frequency of the microwaves. Not that much the distance, so that was another weird thing. So there was not a kind of an inverse, like we would expect with anything electromagnetic, that the inverse of the square of the distance would, you know, be the size of the effect. But yeah, still couldn't explain why it would tilt to the west. And they came up to two different theories. So that idea of the big G started them thinking about fields, about gravitational fields. And, you know, one of the things that they considered was a decoupling between the inertia and the mass. You would say, and I would say, and anybody in our day would say, that makes no sense. Inertia is a property of mass. You can't decouple them. You can't have, you know, for the same object, different inertia and mass changing whatever reason. But if you let that happen, if you assume that could happen, you could explain what was going on. So that decoupling, you know, was in the initial steps of trying to explain what was happening. One thing that came to mind to them was, you know, the weight, the mass would kind of disappear, but the inertia would still be there. And in other cases, it would be the other way around. One of them, I can't remember which one, remember this effect that happens in superconductors when they are in magnetic fields, that I think it's called flux pinning or something like that. You probably saw it, that you have something that is a superconductor, usually really cold, and you have some magnets, and you put that and it kind of floats over, right? And you can move it and put it in another place, but it keeps floating. And the way that works is, well, there's some imperfections that kind of trap the magnetic field in one place, so that becomes kind of a low energy, so it's more than the weight of the object, so kind of that leaves locked there. So they started toying with this idea of, okay, could we be seeing something similar, but instead of magnet, we're looking at, at gravitational fields? And that could be. So things seem to get locked in a gravitational field, in particular the gravitational field of the Earth. But also the other thing that they were seeing was that there was some vibration, some slight vibration in the alloy, in the object. Not enough to even hit it at all, it was undetectable. But they came up with this other theory that they call it gravitational resonance. In gravitational resonance, the hypothesis was that the object is deforming the Earth. Well, it does, right? So the Earth attracts objects, but the objects also attract the Earth. And you know, if you hang something, it gets deformed by the gravitational field of the Earth. Is so much bigger that you basically can ignore the mass and the gravitational force that object, you know, pulls the Earth. So with the gravitational resonance, they could find some equations that would show that vibration that they were observing in the atoms corresponded to the deformation of the Earth. That is completely undetectable. But in theory, you can explain it. So how the Earth is deformed by the object. And those two, when they correlate, it produces a resonance in the object and also in the Earth, you know, and that kept that object locked in the gravitational field. So all those ideas started to come together and try to explain that. At that point, their research started to cause some attention, especially from the military. And the military were interested in exploring the possibilities of what they were finding. Right? So now finally they had some money, they had some research facilities, they had some personnel that they could use, and they start making more and more findings. And other countries at the same time also starting to do their own research. The research was mainly in the practical part, to find better alloys, and then they realized that it didn't need to have to be alloys in the metallic sense, but even composites, some very weird composites that will have that effect more and more prevalent. to the point in which was observable, right? So you could see things that, lost weight significantly when were exposed at certain frequencies, microwave frequencies. So I asked the visitor, well, why don't we see it every day now? His explanation was that these composites are so weird. It's kind of, why don't you eat chicken with marmalade? Or, well, I do, orange chicken, but weird things that, I never think about preparing that because it has no use. It would taste horrible. Well, the same thing, he said. Well, all these things that they found, they had no other use, right? So they were never produced in any way. And in nature, they don't happen. So it was kind of a discovery of all these things. And probably one of the things that allowed them to nail this theory to gravitation was this, shift towards the West. Because now that they had labs in different places, they observed that shift to the West was always happening. And finally, the way they explain it is that with the rotation of the Earth, right? In a way, they explain that, when in a kind of Einstein relativistic explanation, that the Earth, when it rotates, it drags the space, right? And that locking, gets also dragged. And that's something that, would happen anywhere, and it was always, in the direction contrary of the rotation of the Earth. So that kind of helped explain, but at the same time, they figured out ways to compensate for that. And they started using polarization. So microwave, like all electromagnetic radiation, goes in all directions, right? But you can apply filters that allow, the waves to happen in only one direction. That's what we call polarized. And you use them for glasses and things like that. They're polarized in one direction. You can do the same thing. So they learn to get control over the behavior of these elements that they were creating by using polarized and by shaping, basically the shape of the object plus the polarization, they could compensate. So in a way, they could start moving things around. They hadn't reached the point of having anything floating, so just taking its own weight, but it was a matter of time. The first time that they could make something float was a composite that was turned into a mesh, and they put that mesh on a disc of aerogel to give them some structure. So that was the first time that they were able to have something float, take its own weight plus the weight of the aerogel. And from then it was just technology, and hundreds of companies around the world were working on their own ways. And the military, they also started to think of this as a weapon, because now you can have bullets, theoretically, that you could throw. You wouldn't be even throwing them. You would just lock them in, the space-time continuum. And when the Earth would move, that object would penetrate whatever. And there were some accidents when they were doing the research. Some accidents that they couldn't explain, but later they understood what was happening. And that knowledge became very useful when they finally decided to go to Mars. So this is kind of what was going on. The other important breakthrough had to do with the frequency of the microwaves. They found some materials, some composites that would actually work not with microwave but with natural light, with solar radiation even. So now you have things floating around, and some of them taking their own weight, and you could have some clever ways to control those things without putting any extra energy except the microwave. But like I say, in the case of the sun was there. So it was not about transforming energy. It was not about chemical energy, like rockets or planes displacing air and producing vacuums, or nothing like that. Nothing like that. It was just locking things in a gravitational field. So the first commercial product, they called it the gravits. And the first version of the gravits were basically 3 cylinders that form a triangle. And they were about this size. And they were connected by rods. Right? So it was very, very sturdy. So those gravits became stronger and stronger. And by stronger, I mean they could not only carry their own weight, but they could have big, large amounts of weight over them. The first one worked with some external microwave generation, but then they had versions that would run on solar radiation. So with those gravits, people now could build things on Earth. There were some attempts to actually create extremely tall buildings, because you didn't have to care about the foundation anymore. Every 10 floors or 10 story or whatever, you would put a set of gravits, and then you could build another 10 and put another set of gravits and so on, and you could build these buildings as tall as you want. The only problem was that that would only work during the day. So somebody came up with the idea of creating a floating island, and it was about 200 meter, or let's say little 200 yards diameter, composed by these gravits, a base of these gravits, and then on top you had kind of a tropical island, and that island would be stuck in the same position in the Earth regarding to the sun. So from the Earth's point of view, it would be rotating, in 24 hours. So there were places in the world that they would see, that island flying through over them. So it was the eternal sunshine, and they have tourism going there. It was a big deal back in the day. Another very important discovery that facilitated a lot of the things is what people in the future call the RCG. And this traveler told me that most of people forgot what that meant. So it became a word in itself. But, funny enough, I have one here. RCG comes from Rubik Cube gravits. And why Rubik Cube? Because they realized that they could put layers of different composites. Now, all these material composites, alloys in general, they were called the Kraussites, so based on Dr. Krauss. But why Rubik cube? Well, because they noticed that if they put different materials in different levels and in different directions, when they rotate them one to the other, in the different directions, they could make the object move in those directions. So the effect would be amplified or reduced, so by rotating this kind of, they were not like this, right? But kind of hundreds of layers of different composite, but the way they would be rotated one to the other could make these things move with no energy, just floating, stuck in the gravitational field. The final breakthrough was when they found some materials that could be powered by background radiation. So what is called the CMB, the cosmic microwave background. So they could tap into that to produce this effect. So now you basically didn't need any other source. You could just use these new discoveries in physics to put things wherever you want in space. With all of this, up to the moment where this traveler was living, the physics were not fully understood. They had theories that some of them explain part, some others explain other. They could never find a unified, theory of all the four fundamental forces in nature. Even though this opened the gate for many more of those theories, but the technological applications were awesome. And now to connect you to the last piece that I was talking. So these explosions that they were seeing, what they realized was that inadvertently some of these composites would lock into the sun's gravitational field. And since the Earth is moving so fast around the sun, once they locked into the sun's gravitational field, that object immediately moved and destroyed everything in its path and itself. And it looked like an explosion. So that explained why that happened, but also made the space travel possible. And this is an interesting thing, because before that, the way you could go to Mars was first by getting in orbit around the Earth, right? Eventually you would add some energy to leave the Earth orbit, and you would go into an elliptic orbit around the sun. Until you got so close to Mars that you would, again, use some energy to kind of stop that orbit and get into an orbit around Mars. So that's the way, space travel between the planets happened, by using the sun as this intermediate elliptical orbit to connect to local orbits. Funny enough, it was the same thing that they could do now, right? It has to be planned, and it was very difficult from a technological point of view, because you couldn't do any of that research in the Earth, because, again, things would explode. But at some point, they were able to create a probe that would lock initially into the gravitational field of the Earth. By using the RCG, they could move that out, and then they could do a smooth enough transition to another RCG, another set of layers that would lock into the sun gradually while unlocking from the Earth. The final piece of this puzzle was to do the same thing when they were reaching to Mars. But now they were not constraint about the distances, because once they lock into a gravitational field, they could go at any speed that they want. These RCG things could really go extremely fast. So that made it possible to go in almost no time to Mars. What was the limitation? Well, the limitation was humans. Some people try to find frequencies and find ways to turn humans into this type of composites. But they try with some bacteria to start with, and then they try with some animals. It didn't go well, as you imagine. So humans were just fragile payload, and you had to be extremely careful, in particular about the accelerations, right? But that also became something quite good, because now you didn't have to use rotation or anything to have artificial gravity like you see in the movies. What they would do, still not ideal, but did work, and did work well enough, is they would accelerate these ships, were more like spheres in a sense, right? Because of the way they had to place all the different gravits around it. But what they would do would accelerate them to produce, artificial. Think about an elevator that goes up and you feel the weight. So they would accelerate so people could be walking inside. They never reach a 1G, but they could reach 0.3, even 0.4 G in that direction. But then they had to slow down. So what will happen is that there was an internal mechanism that would rotate the whole thing, right, while it starts stopping all the way to zero. If you think about it, it's a similar thing that you do in the planes, that you go up and down following a parabola, so you have zero gravity, and then you have twice the gravity, and then zero gravity. Well, this is kind of the same idea, but you had 0.4 gravity, then it would rotate, so that was the only part that was kind of, you had to get used to that, and then, it will be slowing down, and you have the gravity in the other direction, but you are in the other direction, so for you it's going to gravity again. So the way they would perceive that was, once in a while, and he never told me. I could do the calculations, I guess, but he never told me how often they did it. But quite frequently, you went from full gravity to rotation, floating around, and then full gravity again. Now, for all this, especially for the pioneering of the idea, both Dr. Krauss and Dr. Rees, even though Dr. Rees passed away before, but posthumously, they got the Nobel Prize in 2040. They arrived to Mars, the first group, they arrived in 2043. So it was kind of a big development. By the time this traveler was leaving, they were still struggling with some military uses. There were still, an arms race related to this technology. On a good note, atomic bombs were completely abandoned. Missiles and everything, nobody cares about those at all anymore. But yeah, this is so powerful that they were still struggling with that. So we rest assured that in the future we haven't solved those problems. So, but it's interesting. I hope that you found this interesting. In the next episode of the Big Puzzle, I want to talk about what can we learn about this story and how can we prepare for when it happens in a better way. Well, that will be for today. Sorry for the long time, and see you in the next one. Bye.